Police officers use the formula V equals the square root of 20L to estimate the speed of a dump truck. V is in miles per hour based on the length L in feet of its skid marks when suddenly braking on a dry asphalt road. At the scene of an accident, a police officer measures a dump truck's skid marks to be 70 feet long. Approximately how fast was the dump truck traveling? The velocity v measured in meters per second of an object can be measured in terms of its mass m, measured in kilograms, and kinetic energy Ek, measured in joules. V is equal to the square root of 2 Ek all over m. What is the kinetic energy of a bowling ball with a mass of 3.63 kilograms that is traveling at 6.1 meters per second? These are examples of real-life applications of radical equations. Any equation containing a radical expression is called a radical equation. When there are two radical expressions in an equation, the efficient way to solve it is to isolate one radical expression, then apply the power principle. That is, if A is equal to B, then A to the power n is equal to B to the power n. Note that the converse is not always true. For example, 6 squared is equal to the square of negative 6, but 6 is not equal to negative 6. Now, recall that the square of the sum of square root of A and square root of B is equal to the product of square root of A plus square root of B and square root of A plus square root of B. Moreover, the square of the sum of square root of A and square root of B is not equal to the square of square root of A plus the square of square root of B. Just like in the previous lesson, when solving radical equations, we always check for extraneous roots. Let us take a look at some examples. In example 1, we are given the square root of 2x plus 8 equals 2. We apply the power principle. We simplify and get 2x plus 8 equals 4. We apply addition property of equality. We subtract 8 from both sides of the equation. We also apply multiplication property of equality. We divide both sides of the equation by 2. We can check our solution as follows. We substitute x equals negative 2. We simplify. The solution set of the radical equation is the set containing negative 2. Let us take a look at example 2. Cube root of 2x minus 1 is equal to 3. We also apply the power principle. We simplify and get 2x minus 1 equals 27. We apply addition property of equality. We add 1 to both sides of the equation. We then apply multiplication property of equality. We divide both sides of the equation by 2. We also check our solution as follows. We substitute x is equal to 14. Then we simplify. The solution set of the radical equation is the set containing 14. In example 3, we are given the fourth root of x squared minus 6x equals 2. Again, we apply the power principle. We simplify and get x squared minus 6x equals 16. We apply addition property of equality. We subtract 16 from both sides of the equation. Then, we factor the quadratic trinomial. We apply the zero product theorem. We also apply addition property of equality. We add 8 to both sides of the equation. We again apply the zero product theorem and the addition property of equality. We subtract 2 from both sides of the equation. We can check our solutions as follows. If x is equal to 8, we substitute x equals 8. Then simplify. If x is equal to negative 2, we substitute x equals negative 2, then simplify. The solution set of the radical equation is the set containing negative 2 and 8. Let us consider example 4. Square root of 2x plus 9 is equal to 2 square root of x. We apply the power principle. We simplify and get 2x plus 9 equals 4x. We apply addition property of equality. We subtract 2x from both sides of the equation. We apply multiplication property of equality. We divide both sides of the equation by 2. We can check our solution as follows. We substitute x equals 9/2. We simplify the left-hand side and use the radical property on the right-hand side. We rationalize the denominator. Then simplify. The solution set of the radical equation is the set containing 9/2. In example 5, we are given the square root of 5x minus 1 plus 3 equals 6. First, we apply addition property of equality. We subtract 3 from both sides of the equation. We apply the power principle. We simplify and get 5x minus 1 equals 9. We apply addition property of equality. We add 1 to both sides of the equation. We also apply multiplication property of equality. We divide both sides of the equation by 5. We can check our solution as follows. We substitute x equals 2. Then we simplify. The solution set of the radical equation is the set containing 2.